So today we'll be talking about waves. We know we have ocean waves, our sound waves, and even our light waves. But what exactly is a wave and how do we define it? Well, a wave can be described as a disturbance that travels through a medium from one location to another, or a transfer of energy from point A to point B. It is also very easy to characterize. Here we have our standard sinusoidal wave. The highest points of the wave are known as the crests, or the peaks, and the lowest points in the wave are known as the troughs. The amplitude is the distance from the baseline to a crest, or the baseline to a trough. In sound waves, the amplitude determines the loudness, or the volume of the sound, and in light waves, it determines the brightness that you see. The wavelength is quite literally the length of the wave. Noted with the Greek letter lambda, it is equal to the distance between corresponding points on consecutive waves. For example, from crest to crest or from trough to trough. The period and frequency of a wave are closely related and are often considered together. The period of a wave, measured in seconds, describes how long it takes for a wave to complete one cycle. The frequency, on the other hand, describes the number of waves that pass a given point in the time period of 1 second. The period and frequency are inverses, meaning the greater the period, the smaller the frequency, and vice versa. With sound waves, the frequency of the wave determines the pitch of the sound that you hear. For example, the lower sounds are characterized by lower frequencies, and the higher pitched sounds are characterized by high frequencies. Now that we have a basic understanding of waves, we can begin to understand the principle of superpositioning, which occurs when two or more waves interact with one another. Superpositioning states that when the waves are in phase, the amplitudes will add up. If the waves are not in phase, the troughs and the crests will cancel each other out, and we will not see any wave. Being in phase basically means that both waves are doing the same thing at the same time. So when one wave is reaching its peak, the other is as well. This simple experiment shows superpositioning in action. The two waves being generated in opposite ends of the tank interfere constructively in some points and destructively in others.